All right, guys, just a quick video going over a couple of the homework problems. So I'm going to do 33 and 35. So for 33, I'm going to do it in this space right here. I have x squared plus 11xy minus 3y squared plus negative 2x squared minus xy plus 4y squared. And so here, since it's addition, I just want to combine my like terms. So x squared is a like term with x squared because they have the same variable and exponent. Remember, there's a coefficient of 1 here. So 1 and negative 2 combine to make negative 1, or we could just write negative x squared. 11xy is a like term with negative xy. Again, there's a 1 there. So 11 and negative 1 make 10. So 10xy is what I get when I combine my like terms. And then negative 3y squared is a like term with 4y squared. So if I add the coefficients, remember this is going to be negative 3 because of the subtraction sign. So negative 3 and positive 4 combine to make positive 1, or I can just write y squared. For 35, 35 is a subtraction problem. So we're going to have to use keep, change, flip in order to do this. So I am going to keep the first polynomial the same when I rewrite this problem. So 8a squared b minus 6a stays the same. I'm going to change it to addition, and then I'm going to flip every sign in the second polynomial. So right now it's positive 2, so I need to flip that to be negative 2a squared b. Right now it's negative 4b, so I'm going to flip that to be positive 4b. And it's positive 19, so I'm going to flip that to be negative 19 by turning it to subtraction. And then from there, it's just combining like terms. So 8a squared b is a like term here because I have a with a 2 and b with really an invisible 1. Same thing here, a with a power of 2, b with a power of 1. And so that gives me 6a squared b. There's no other a terms, so it's going to stay negative 6a. There's no other b terms, so it stays 4b. And there's no other 19 term or constant terms, so it's going to stay negative 19. All right, here's 39. I know people see word problems and they kind of clam up, but let's just try it. So during the period of 1998 to 2002, the number A in millions of books for adults and the number J in millions of books for juveniles sold can be modeled by these two equations. And so T is the number of years since 1998, and they want me to write an equation that gives the total number of books for adults and juveniles. So for A, all I need to do is take the adult equation and add it with the juvenile equation. So I have 9.5t cubed minus 58t squared plus 66t plus 500 being added with negative 15t squared plus 64t plus 360. So now all we do is add. So we're going to combine like terms. This is my only t cubed problem or term. Then I have negative 58t squared and negative 15t squared. So that's going to give me a total of 73t squared. 66t plus 64t is going to give me 130t, and 500 and 360 are going to give me 860. That's all A is looking for, just the combined total polynomial. B is asking, were more books sold in 1998 or 2002? Well, they told us up here, T is representing the number of years since 1998. So if I wanted to calculate how many books were sold in 1998, how many years is that since 1998? Well, it's 0 years. So for this one, T equals 0. To figure out 2002, 2002 is 4 years after 1998. So T is going to be 4. So I essentially want to do this expression twice. I want to do it for 1998 And I'm going to do that by plugging in 0 for t. I like to do parentheses when I plug something in. All I'm going to do is take my calculator and figure out what this is. This one's really easy because this is going to be 0, this is going to be 0, this is going to be 0. So in 1998, there were 860 million, because this was in million, books sold. Then they want us to do 2002, so we're going to do the same thing using 4 now for t. And this one's not as easy because 4 is not going to cancel to be 0 like 0 is. So what you can do is you can go to Desmos Scientific Calculator. It's linked in your overview. And we can just type that equation in. So I can do 9.5 times 4 to the third plus minus 73 4 squared plus 130 times 4 plus 860. And so in that year, 820 million books were sold. So more were sold in 1998. Question 41 is very similar to this one, so I do want you to try that one on your own.